Hello everyone. The repair of the Mercedes-Benz 442 engine, 8-cylinder, V-shaped, turbocharged, with a piston diameter of 128 mm. After using diesel fuel, we clean and steam the block in our washer. This is the washer we use. Now I need to measure the crankshaft, the main journals, and the connecting rod journals to see if they are within spec or not. To do this, I need to check it for bending, and for that I'll need V-blocks and a dial indicator. So, I've checked the crankshaft, it's in perfect condition. Now, I need to check the cylinder block and measure the diameter of the holes for the main bearings. Alright, the block is ready, everything is basically prepared, so I'm starting the assembly. Hello Alexander. First of all, I'll be replacing the camshaft bushings. It's a dynamic process. Alright, first I'm gonna knock out the old ones. The bushings are installed. The most important thing here is to make sure that this oil channel lines up with the hole. The second hole is for the oil supply to the fuel pump. So we see that both holes line up, and in these there's just one channel from the main bearing shell that supplies oil for lubrication. For the camshaft support journals, we see that all the holes line up. That's it. The next step is installing the cylinder liners. These kinds of rubber seals, in my opinion, they're the best one, and over time they stay just like that. Brown, thin rubber seals are installed on the cylinder liners. So one cylinder liner needs to be replaced. The rubber seals are installed. Okay, the rubber seals are on. Now we take special silicone grease and apply it to the places where the seals sit.
If you don't have special grease, you can just use oil.
So here Alexander asked me if you can use sealant to lubricate the rubber seals or not. Basically you can. Why not? While it's still liquid, it will act as a lubricant so the sleeve goes in smoothly. But then when it dries, basically it's an extra seal, so there's nothing wrong with that.
I'm also lubricating the lower rubber seal.
Lubricate the rubber seals inside the block as well. All sleeves have been lubricated. The block is also lubricated. Now I need to put these rings, the brass ones. That's at my sleeve. As we continue, the sleeves are in place. Installed new sleeve on 5th cylinder. So next I'm installing the plug, a little sealant on the end. So Next I'll be installing the camshaft, but before I do that I need to replace this ring under the oil seal. You can see the wear on it. Here's the new ring. While I'm removing the old one, I'll put the new one on the stove and heat it up since it needs to be installed hot. Alright, let it heat up. I'll be removing the old ring using a hammer and with this kind of valve screwdriver sharpened like this. It rests against the edge and doesn't damage the seat for this ring. And I also want to say, be sure to use safety glasses because fragments from this ring can fly off, so safety glasses are a must. So the ring is heated up. Theoretically it should fit in now. Alright, the ring is in place. I can insert the shaft, but before inserting the shaft I need to put in the lifters because it will be inconvenient later. So we take some oil and lubricate the channels. Alright, so we insert it into the slot. If we have oversized bearings, we definitely need to take and measure the thrust bearing with the thrust ring. On the shaft, everything fits well. It has a little plate just as it should. The bearings with channels and a hole are installed in the block. So that oil goes to lubricate the camshaft bushing, and the solid bearings are installed in the cap. Now I'll tighten the shaft. The shaft is tightened like this, 100, 200, 300. Then another 90-degree angle.
Basically, I tightened it to 300.
Marks across. And after 90 degrees, the marks are lengthwise. That's it. The shaft is fully tightened. This is how it spins. That is, it's perfect. I give it a little force, and then it keeps going on its own. Axial plane. About a tenth. Perfect. Now we can install the camshaft right away. I didn't install it before because I wanted to see how the crankshaft spins by itself without the camshaft adding any extra resistance. Now we can install the camshaft. Here I've lined up the mark at the bottom. I need to lubricate it with oil. That is, I've already lubricated the bushing. Here we see the marks. There are two ones. On the camshaft and on the crankshaft, sometimes there are also ones, sometimes just a dot. Five, 4, 3, 2, 1. All right, I'm looking at the piston. I'm checking the piston, the pins, piston. It will be fine. Let's oil it. I'm measuring the rings. The gaps are perfect, the oil control ones. The second compression ring. The first compression ring. I'm staggering them at 120 degrees. My pistons are ready. Now, I need to install the bearings, and I definitely need to measure the length of the bolts. So, the maximum allowable underhead length of the connecting rod cap bolts is 68.5. That's why it's essential to measure all the bolts. Look, 68.2. Well, I've measured all of them already. All the bolts are good. Bearings. The bearings are only used on turbocharged engines. So regular bearings from a non-turbo engine won't fit. Here, the lower bearing that goes into the connecting rod is reinforced. So the white one goes into the cap and the shiny one goes into the connecting rod. So here we see the inscription sputter. By the way, these bearings are very expensive. The one that goes into the cap is white without the sputter inscription. I'm starting to install the pistons. They're installed. Now I'm starting to tighten them. The tightening torque is 98 Newton meters, roughly 100 or 10 kilogram force, And then the final tightening is 90 degrees. So what else I want to say is that after tightening, the rods must move freely with just a little effort from your hand. That's the first point. And the second thing we definitely check is the number on the connecting rod itself. And the number on the rod cap, 599, 599. So we check again. It's essential to make sure the rods and caps are mixed up. 175, 175. The crankshaft is in place, everything is tightened, the main bearings are tightened, the side bearings are also tightened, and the connecting rod journals are torqued. I also marked it, turned it 90 degrees, then installed the counterweights and torqued everything as well. So the shaft is already fully installed in place. Now I'm installing the front cover, the special air link 1 continuation. Alright, now I'm installing the oil seal and putting on the cover. Okay, the oil seal is in. I applied some sealant. A special tool is included with the oil seals for installation continuation. So, about the heat exchanger, I removed it, washed the radiator, cleaned it. Next is the drain plug. Here's the drain plug, it's in place. Well, it was already all stripped. I wanted to replace it with another one, but I couldn't unscrew it, I had to drill it out. This is a 14mm plug. I cut a 16mm thread and put in another plug. That's it. Now I'm putting the radiator back in place and installing the heat exchanger. So I'm installing the heat exchanger. I didn't check the factory gasket, it's a bit different. The oil passage here and the rib are positioned differently. I had to make a custom gasket in another spot. The cylinders are in place. Now I'll be installing the head. It's already assembled. Alright, the compressor is ready. Now I just need to fit the bark myself. I prefer these kinds of seals, they're labeled as acrylic rubber, something like that. Alright, next I install the cover, but before I do that, I check the timing marks one more time. I check the timing marks, we see that on the camshaft. There are two ones, and on the crankshaft the tooth is between these ones. For the gaskets I use purling. To be continued. They are metal asbestos, which is very important because there is a lot of force on the cover and this connection. So if you use just cardboard gaskets, they get squeezed out, but these are metal asbestos. That's it, I'm applying sealant and installing it. Alright, the cover is installed. Next we'll close up the oil pump. Okay, so let me explain. The plan was to install a new oil pump on the engine. Here it is from BF company, and the new Capostoni valve. But during the inspection, so I supply air here and spin the pump with air. And during the inspection, when air is supplied, the pump starts to vibrate. So this kind of vibration happens. I've been working for many years, and this is the first time I've seen something like this, but it turns out this can happen too. So my only explanation is that this gear is simply not balanced. Maybe it's thicker here, thinner there. It just hasn't been balanced yet, and that's why I didn't risk installing this pump. So there will constantly be this vibration, this constant load, and I don't know that the gear could spin on the shaft, break, anything could happen. That's why we decided to keep the old pump. I did a quick inspection on it, opened it up and checked visually, saw there was no wear anywhere, spun it in diesel, and it pumps diesel perfectly. That is, if you block it with your hand, you can't hold it back with your hand, even when turning it calmly like that. I made marks, took it out, checked the condition of the splines, checked the condition of the gears, everything is fine. So I'm installing the old pump with the new electronic valve, installing the pump dynamically. Alright, the pump is in place. Next, I'm installing the pan. The tray has been washed and cleaned. Before putting the pan back on, I rotate it once more and carefully check everything. To be continued. I applied some grease, put the gasket on, and applied some here as well. Very thinly, you don't need a lot. Alright, we take a new plug with a magnet and a new washer. I'll tighten it now so we can add the oil right away. So this is how it all looks. The oil pan is tightened. I've tightened the plug too. I don't have the flywheel yet. I'll install the flywheel later. The engine is flipped over, I've put the gaskets on. That's it, we can install the heads now. Let's go. Alright, so I'm starting to install the pump. That is, we align the stationary mark, which is on the plate on the pump housing, with the movable one, which is on the hub. Since the pump is electronically controlled, the camshaft just comes without weights, just a gear, because it's electronically controlled. If the pump has a mechanical throttle linkage, then there will be mechanical ignition advanced with springs and weights here, and the camshafts will not be interchangeable. Alright, the cover is in place, the pump is in place, the cover is in place. I washed the push rods. Now I need to check them for bending, like this. So, to adjust the valves, I'll need a valve adjusting screwdriver or another strong screwdriver. A 0.4, 0.6, 0.4 filler gauge for the intake valve, 0.6 for the exhaust, and the 17 mm box and wrench. Next, I install the injectors. My injectors have been checked, cleaned, washed, in. And I have new washers ready, which should be the original ones with a thickness of 1.5 mm and new nuts. Everything here has been cleaned. Pin, it's clean and blown through. First, I throw it in there. The washers. Alright, next I install the valve covers. Let's continue. I washed, cleaned, prepared the bolts in that new gasket.
Continuation, subtitle editor.
Put the valve covers on. I'm cutting the return hose into 25cm pieces. Cut them now and putting them on. So, next up on my list is repairing the pump. Basically, it wasn't really leaking. We decided to fix the pump while we're working on the engine anyway. There's some play in it. We could keep going, but since we're here, let's do it now. One set. The kit includes the fiber gasket, all the gasket thermostat seals, new impellers, and then so it's a complete set. So I won't be filming the entire repair. I have a separate video on my channel dedicated to the pump repair. So if you're interested, I'll leave the link below in the description. I disassembled the pump, washed and cleaned everything. At first I thought I wouldn't remove the thermostats, but then when I took it out, I saw through this window here that, as you can see, the rubber gasket is sticking out. I realized that the thermostats were installed incorrectly. First they put the gasket in, then the thermostat, although it should be the other way around, first the thermostat, then the gasket. Yeah, the cover here is already pretty eaten away. Lots of corrosion. And there are a bunch of gaskets everywhere, both on top and underneath. There shouldn't be a gasket on the bottom at all. Look where it got pulled to. When I press in the bearing, I won't press on the shaft with a socket like this, just on the race. Alright, that's it. My pump is ready. So this is how it looks now. Naturally, there's no play at all now because the bearings are new. First, the thermostat is installed. This is how the thermostats are installed. Then the rubber ring is installed, and then the cover is installed. I ground the cover down a bit on a grinder, on a grinding wheel. There are already pits here. Nothing can be done. Well, basically, it should still work fine with a gasket like this. It's not included in every set, so I'll put it here now. Apply some sealant as well, and everything will be great. That's it, the pump is ready. Next we'll install the flywheel. We grab a new bearing. install the flywheel. Take it off, take it off. Take it off. Roughly align the guides and the slot for it. Take it off. Take it off and make sure to check the guide so that it's visible. Make sure everything is in place, that's it. Now take the bolts and tighten them. I don't have any manifolds, neither intake nor exhaust manifolds. So that's everything I had. I've installed it all.